Here's integrated 3. It's problem 6-58. It has letter A, B, C, and D. And it's a checkpoint problem. It wants me to determine the solutions using any method I choose. So I'm going to try to do all 4 of them in less than 10 minutes. So I'm going to go super fast. But basically, this is your algebra. You're solving for x. So this one, the way I would do it is I would square both sides. This I can square out in my mind. It would be x squared, and then it'd be this times 2. So minus 4x, and then this squared. And then I'm going to get them all on the same side of the equal sign. Now I have a quadratic. So x equals 7, x equals negative 2. I plug them back in and find out why, but we didn't have any y's in this one. Oh, you know what I should do though? I should plug them back in because what if something doesn't work? You know, what if they're not both solutions? So let's plug the 7 in. 7 plus 18, take the square root. What is 18 plus 7? 20, that's 25. If I take the square root, is that equal to x? Sorry, 7 minus 5. Wait, what? Here's the original equation. So 7 plus 18 was 25. So I couldn't do that in my head for some reason. This is 5 equals 5. So this equation works, or this number works. If I plug the negative 2 in, then it would be negative 2 plus 18 equals negative 2 minus 2. Well, I already know there's a problem here because I'm going to get 16. And when I take the square root of 16, I get positive 4, not negative 4. So this is the only answer for letter A. So letter A was already a trick question. Sorry. Letter B. So I think to solve this, I think I'm going to do that thing where whatever's in here, the positive or negative, it can be the positive or the negative version of it, if that makes any sense. So like, you know how when I take the square root of something, like the square root of x equals 3, you know how like this could either be positive or negative 3 and it'd still be, the absolute value would be 3. So that's kind of what I'm doing here. I'm writing it 2 different ways. So I just wrote it the way the original equation had it, and then I just wrote the opposite because we know that the exact opposite, like this could be negative 3 in here. So I wrote it. See, I took the negative of each of the numbers, and I'm just going to solve it twice and get some answers here. So I think I'll add 2x. So x equals 2, and I'll check these once I'm all done. And then x equals 12. And I want to see if they both work. So 2 plus 3 is 6. And then negative 2 times 2, that's negative 4 plus 9. That's also 6. So this one checked out. 12 plus 3 is 15. And then negative 2 times 12 is negative 24 plus 9. Well, that's negative 15. So this one doesn't work. It like almost works, but it's just that you can't have a negative 15. So this part is not a solution. When I plug it in, it didn't work out, but this is a solution. So that was letter B. These are all tricky ones. Okay, letter C, I'm allowed to use any method I want. This one has x's and y's. This one's almost solved for y, so I'm just going to subtract the 3x on both sides. Like I'm going to, I think I'm going to use equal values on this one. I'm going to say that y equals 1 minus 3x, and on this one I'm going to say that y equals 2x cubed, squared, minus 5x minus 3. So now I have them both set equal to y, and I can use equal values. And then I'll get everything over here on the right-hand side. And then I'll do a diamond problem on it. Did it work? Let's see. Okay, so this thing is so this, I'm doing this in my mind. I'm setting it equal to 0, bring the 4 to the other side, divide both sides by 2. Maybe I should just not do it in my head. The x equals 2. So for 6-58, x equals, I should have been a little more careful, x equals -1 and x equals 2. But, and then I think I'm done. I think I'm done, but I'm not, because I have to find the y values. So here's my 2 ordered pairs. And I got to find the y that goes with it. And here's my other one, and I've got to find the y that goes with it. So it's probably, this equation right here is probably the easiest. Here, let's fix that. This equation right here is probably the easiest one to plug things into. So when x is -1, I've got 1 minus 3 times -1. So that's 1 plus 3. I get 4, I think. So that's one of my answers. And then plug a 2 in. I've got 1 minus 3 times 2. 3 times 2 is 6. So 1 minus 6 is -5. Now I'm in a hurry because I'm trying to make these under 10 minutes. I probably already have run out of time. This one I'm going to use that one where you can add the, Wait, this one looks like I could use equal values on it though, huh? Or I could use elimination. I'm going to go crazy and use elimination. Elimination is when you can add them up and something gets eliminated. So I'm going to add these two equations. Y plus y is 2y. These two, when I add them, go away. This plus this is 4x. Oh, maybe that won't work. And then minus 7. Changed my mind. I'm going to do it the other way. I'm going to use equal values. I think I still could have probably done something with that, but I don't want to mess around with it when I'm trying to make this video. These should all cancel out. So now I have a quadratic, and I could try to factor it. I could find out what 4 times 21 is. 4 times 21 is 84. It's going to be kind of hard to guess these numbers at negative 20. So I can think of numbers like 7 times 12. I think I'm going to use quadratic formula. I think it can factor, but I think it might take a little too long if I do it like that. So negative b plus or minus square root b squared. So b squared would be 400 minus 4 times a times c all over 2 times a. So see, I knew it would factor, but I just didn't have the patience. So 20 plus 8 over 8, or 20 minus 8 over 8. So 28 over 8. 28 over 8. Well, 4 goes into both of those, so that could be 7/2. 20 minus 8 is, I think, 12. 12 over 8. So 4 goes into both of those. So that's okay. So those were x values. So I'm making ordered pairs for them. So I plug in the 7/2 in somewhere. Well, I think I'm going to actually speed through that. If I plug my 7/2 in, I should be